Welcome to the NewsX World Explainer Series. I'm Rashawn Gidwani. In aerospace engineering, pushing a newly redesigned mega rocket to its absolute limits means embracing both spectacular milestones in orbit and explosive conclusions in the sea. And that's what we'll be discussing on this explainer. The highly anticipated 12th integrated test flight of SpaceX's Starship program marked the dramatic debut of the version 3 launch vehicle configuration, the largest, heaviest, and most powerful rocket ever assembled. Standing at an unprecedented 408 feet, which is 124 meters tall, the stainless steel behemoth features a substantially elongated super heavy booster. This new V3 architecture swaps out the cluttered exterior plumbing of older models for streamlined, shield-free Raptor 3 engines, sports significantly beefier grid fins for atmospheric steering, and incorporates a massive fuel transfer tube driven by 33 main Raptor engines, generating 18 million pounds of thrust. This radical clean sheet redesign is engineered to boost the payload capacity to a staggering 100 metric tons, a capability critical to both SpaceX's expanding Starlink network and NASA's Artemis lunar ambitions. So what's this all mean? Payload capacity is the maximum safe weight a vehicle, aircraft, or vessel can carry, including passengers, cargo, and equipment. 100 metric tons is not light. Let me tell you more. The flight profile and strategy for this mission focus tightly on testing commercial readiness and hardware endurance rather than vehicle recovery, utilizing a trajectory that sent the rocket soaring from a brand new second launch pad at Starbase, Texas. The primary ascent went smoothly through the initial stages, utilizing a reusable hot staging ring to execute clean separation between the two stages, while the upper stage seamlessly coasted into its planned suborbital cruise phase, successfully deploying 20 mock Starlink satellites and utilizing a pair of secondary camera-equipped free flyer satellites to beam back unprecedented live views of its heat shield. During ascent, Ship 39 suffered an early dropout of one of its 6 engines, prompting mission controllers to scrap a planned in-space engine reignition test. Meanwhile, the Super Heavy booster faced much more severe propulsion issues during its post-separation boost back sequence, where a major relight failure failed. There was a total loss of control which destroyed the booster over the Gulf of Mexico before it could attempt its targeted controlled descent. Now, despite these mid-flight hiccups, the upper stage pushed through severe atmospheric re-entry plasma, surviving deliberate high-stress maneuvers to execute its final vertical landing flip over the Indian Ocean. The mission reached its explosive conclusion roughly 65 minutes after liftoff, when Ship 39 touched down on the water, tipped over, and erupted into a massive fireball, a destination and outcome fully expected by SpaceX engineers for this expendable flight profile. With the baseline V3 architecture now flight proven and invaluable telemetry data secured from the heat shield cameras, SpaceX is already pivoting to what's next. Engineers are working to iron out the Raptor 3 relight anomalies. This will be done before Flight 13, which aims to push the V3 platform into a sustained full Earth orbit to test complex operations like in-space refueling. All of this will keep the company on track for its targeted commercial payload deliveries and a history-making public market debut. Should we ever expect any less from Elon Musk? Thank you for watching. Stay tuned with NewsX World for fact-based coverage and analysis.